You're on. Go.
Okay, so today I'm going to be talking a little about thermal cameras and how they're up and coming. Now, the reason thermal cameras are really the up and coming thing is your traditional cameras basically have a physical limitation. They need light to work. Now, sure, some network cameras have night and day functionality that allows them to operate in very poor lighting conditions, down to a fraction of a lux. And of course, there is the natural light, and if that's not available, you do have, IR light, which is infrared light illumination. But with thermal network cameras, it's really a perfect way to complement any IP surveillance system. It can be seamlessly combined with any existing equipment, and it's possible to secure an area or perimeter that lies in a complete darkness. Okay. Now, with thermal imaging, it's nothing new. But until recently, costs have usually been, pretty high, making it unpractical to really, outside that government application, to have it. And it's all started to change with new sensors, new materials. You're seeing them more out there in the industry, like aircraft, shipping, security, and obviously surveillance. Even some firefighting and law enforcement have them. And it's funny, you even see it sometimes in some luxurious cars that are out there. Of course, now understand with thermal imaging, it works on two ways. It works actually with a cooled sensor or an uncooled sensor. Okay, with the cooled infrared detectors that are in these, they're usually contained in a vacuum sealed case, and they're cooled in temperatures as low as -346 to 274 Fahrenheit. Okay, so it depends on the type of level that you want or the performance that you're desiring. These extremely low temperatures are accomplished with so-called cryogenic coolers. Okay, the cooling is needed to reduce them thermally, which at higher temperatures the sensors risk being flooded though or blinded by their own natural radiation. The equipment not only makes the detectors relatively bulky, but mainly expensive. But please understand, cooled detectors can distinguish small temperature differences and produce crisp, high-resolution images. Another advantage is that the greater sensitivity also allows the use of f-number lenses. Okay? With the uncooled sensors, these are thermal cameras are not dependent on the cryogenic cooling. In this case, the sensor is stabilized or at close to ambient temperatures that the camera's in, okay, using less complicated temperature control elements. Sensors of this kind operate in long-wave infrared band also, okay. The uncooled thermal imaging sensors are smaller, and they're built with fewer moving parts. Not only does this make them less expensive than the cooled, but also allows them for longer service intervals. Meaning basically they don't, with the typical cooled sensor, it's basically every 8 to 10,000 hours they have to be redone. With the uncooled, they could run really continuously for years. Okay, wow. And the great thing, if you think about it, is come rain or shine, thermal cameras can either work well in perfectly well lit areas or complete total darkness. Okay.
Yeah. I've got that.
Okay. More troublesome, the sort of the kryptonite with thermal cameras, though, is you got to understand it's glass. Okay, so and the big problem with that is you can't take a regular traditional housing that you use for a regular camera, because these usually use what we call a standard CS or mount or C, which cannot be used because of that glass. Right. So manufacturers therefore have to rely on other materials. Presently, it's called germanium, which is most used in thermal camera optics. It's very expensive, but it works, obviously. Naturally, that's the one that we would prefer that anyone use.
No, I've got it, Pete. You'll have to pardon me. We're getting a Skype call in here from one of our people that's coming on after you, so I pardon the interruption there. But with the glass and the expense involved in that, does that make it cost prohibitive for people in the industry to actually implement this type of technology?
No, costs have come down dramatically. I mean, you years ago, literally a few years ago, you would spend at least 50,000. If you were to get a thermal camera, especially if you got one with a 640 by 4080 resolution.
Right.
It literally costs about 50,000. Now you can get them around 2,000 easily. So the costs have come down dramatically, and depending on the performance you want, you can get them cheaper, but the performance is, it does vary. Okay.
Yeah. Okay. Anything else in the thermal camera area? I think some of our people may be aware of the thermal imaging technology that's out there. I don't know if they're aware that all of this has just, kind of crosswalked over into the regular, what I would call the traditional CCTV community. That's pretty hot stuff.
Well, we're actually seeing them pretty commonly used in the boating industry, literally on docks, everything like that, because of how sensitive they are, as where a regular camera in a complete darkness, you're not going to see things. But you can see things with the thermal camera because of that temperature. So this is one application that we've seen them being used in, even in police cars now, for them trying to catch the bad guys. This is other applications we've seen them in. Retail has started to use them, and understand this is sort of a supplementary to really complement any kind of network system already in place. It's not going to be really the sole camera that you're going to have in any kind of surveillance system. It's more to complement, to see things that you normally wouldn't see.
Yeah, I hear you. Anything else in the industry so far as the thermal cameras are concerned right now? Anything else we need to know?
That was pretty much all I had really to talk about.
That's fine. That's fine. That's it, Don. I appreciate it. We thank you for the update, and that's our Access Communication industry update on CCTV this week. Thank you, and give our regards to everybody back at the shop.
All right, take care.
All right, thank you again.